Welcome. Today we're diving into the fascinating world of narrow AI and exploring how machine learning is at the heart of its development. Narrow AI, also known as weak AI, refers to artificial intelligence systems that are designed to perform a specific task or a limited range of tasks. Unlike general AI, which aims to mimic human intelligence across a broad spectrum, narrow AI focuses on specialized functions. From voice assistants to recommendation engines, narrow AI is already shaping our daily lives. But what exactly powers these smart systems? The answer lies in machine learning, a field that enables computers to learn from data and improve over time. Start by defining machine learning. Machine learning is a subset of artificial intelligence that allows systems to automatically learn and adapt from experience without being explicitly programmed. It uses algorithms to analyze data, identify patterns, and make decisions with minimal human intervention. This ability to learn from data is what sets machine learning apart from traditional programming. In narrow AI, machine learning algorithms are tailored to solve specific problems such as recognizing images, translating languages, or predicting user preferences. The more data these algorithms process, the better they become at their assigned tasks. Narrow AI is distinct from general AI in its scope and capabilities. While general AI aspires to perform any intellectual task a human can, narrow AI is limited to specific domains. For example, a spam filter is excellent at identifying unwanted emails but cannot drive a car or play chess. This specialization makes narrow AI highly efficient and reliable for targeted applications. Machine learning is the engine that drives this efficiency, enabling narrow AI systems to excel in their chosen fields by constantly learning from new data and refining their performance. Machine learning relies on a variety of algorithms to process data and make predictions. Some of the most common types include supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the algorithm is trained on labeled data, learning to map inputs to outputs. Unsupervised learning, on the other hand, deals with unlabeled data and seeks to find hidden patterns. Reinforcement learning involves learning through trial and error, receiving feedback from actions taken. Each of these approaches plays a crucial role in the development of narrow AI systems. Supervised learning is perhaps the most widely used machine learning approach in narrow AI. It involves training a model on a dataset where the correct answers are already known. For example, in email spam detection, the algorithm learns to distinguish between spam and legitimate messages by analyzing thousands of labeled examples. Over time, the model becomes highly accurate at identifying spam, making it a valuable tool for email providers. This method is also used in image recognition, speech recognition, and many other applications. Supervised learning is another important technique in machine learning. Unlike supervised learning, it works with data that hasn't been labeled. The goal is to find patterns or groupings within the data. For instance, unsupervised learning can be used to segment customers based on purchasing behavior, helping businesses tailor their marketing strategies. In narrow AI, this approach is valuable for discovering hidden structures in data, such as clustering similar items or detecting anomalies. Reinforcement learning is a unique machine learning method where an agent learns by interacting with its environment. The agent receives feedback in the form of rewards or penalties and adjusts its actions accordingly. This approach is commonly used in robotics, game playing, and autonomous systems. In narrow AI, reinforcement learning enables systems to optimize their performance over time, learning the best strategies through continuous trial and error. Data is the lifeblood of machine learning. Without large and diverse datasets, machine learning algorithms cannot learn effectively. In narrow AI, the quality and quantity of data directly impact the system's performance. For example, a voice assistant trained on a wide range of accents and languages will perform better than one with limited data. Collecting, cleaning, and organizing data are essential steps in building robust narrow AI applications. Feature engineering is the process of selecting and transforming raw data into meaningful inputs for machine learning models. In narrow AI, this step is crucial for improving model accuracy. By identifying the most relevant features, such as keywords in text or pixel values in images, engineers can help algorithms focus on what matters most. Effective feature engineering often requires domain expertise and creativity, making it a key part of the machine learning workflow. Training a machine learning model involves feeding it data and allowing it to learn patterns and relationships. In narrow AI, this process is repeated many times, with the model adjusting its parameters to minimize errors. The goal is to create a model that can generalize well to new unseen data. Training can be computationally intensive, often requiring powerful hardware and specialized software. Once trained, the model is ready to make predictions or decisions in real-world scenarios. After training, it's important to validate and test the machine learning model. Validation involves checking the model's performance on a separate dataset to ensure it hasn't simply memorized the training data. Testing goes a step further, evaluating how well the model performs in real-world situations. In narrow AI, rigorous validation and testing are essential for building reliable and trustworthy systems that users can depend on. Once a machine learning model has been trained and tested, it's ready for deployment. In narrow AI, deployment means integrating the model into a real-world application, such as a chatbot recommendation system or fraud detection tool. This step often involves additional considerations like scalability, security, and user experience. Successful deployment ensures that the benefits of machine learning reach end users effectively and efficiently. Machine learning models in narrow AI often continue to learn after deployment. By collecting new data and monitoring performance, these systems can adapt to changing conditions and improve over time. This process, known as continuous learning, is vital for applications where data evolves rapidly, such as social media analysis or financial forecasting. Continuous learning helps narrow AI stay relevant and effective in dynamic environments. Voice assistants like Siri and Alexa are prime examples of narrow AI powered by machine learning. These systems use speech recognition algorithms to understand spoken commands and respond appropriately. By learning from vast amounts of voice data, they can recognize different accents, languages, and even individual speaking styles. Machine learning enables these assistants to become more accurate and helpful with each interaction. Recommendation systems, such as those used by Netflix or Amazon, are another application of narrow AI and machine learning. These systems analyze user behavior and preferences to suggest movies, products, or content. By processing massive datasets, machine learning algorithms can identify patterns and make personalized recommendations. This not only enhances user experience but also drives engagement and sales for businesses. Fraud detection is a critical area where narrow AI and machine learning shine. Financial institutions use machine learning models to analyze transaction data and detect unusual patterns that may indicate fraud. These systems can quickly adapt to new types of fraud by learning from recent data, making them more effective than traditional rule-based approaches. Machine learning helps protect both businesses and consumers from financial losses. Healthcare, narrow AI powered by machine learning is revolutionizing image recognition. Algorithms can analyze medical images such as X-rays or MRIs to detect diseases and abnormalities with high accuracy. By learning from thousands of annotated images, these systems assist doctors in making faster and more accurate diagnoses. Machine learning is helping to improve patient outcomes and streamline healthcare processes. Natural language processing, or NLP, is a field of narrow AI that focuses on enabling computers to understand and generate human language. Machine learning algorithms are used to analyze text, translate languages, and even generate written content. NLP powers applications like chatbots, language translation services, and sentiment analysis tools. By learning from vast amounts of text data, these systems become increasingly proficient at understanding human communication. Autonomous vehicles, such as self-driving cars, rely heavily on narrow AI and machine learning. These systems process data from sensors, cameras, and GPS to navigate roads and avoid obstacles. Machine learning algorithms help vehicles recognize traffic signs, pedestrians, and other vehicles, making real-time decisions to ensure safety. While fully autonomous vehicles are still in development, narrow AI is already enhancing driver assistance systems. Personalized marketing is another area where narrow AI and machine learning make a big impact. By analyzing customer data, machine learning models can predict which products or messages will resonate with individual users. This allows businesses to deliver targeted advertisements and promotions, increasing the likelihood of conversion. Machine learning helps marketers understand their audience and optimize campaigns for better results. Chatbots powered by narrow AI and machine learning are transforming customer service. These virtual assistants can handle routine inquiries, provide information, and even resolve issues without human intervention. By learning from past interactions, chatbots become more effective at understanding and responding to customer needs. This not only improves efficiency, but also enhances the overall customer experience. Spam filters are a classic example of narrow AI using machine learning. These systems analyze incoming emails and classify them as spam or legitimate based on patterns learned from previous messages. By continuously updating their models with new data, spam filters can adapt to evolving tactics used by spammers. Machine learning ensures that users' inboxes remain clean and secure. Predictive text features on smartphones and computers are powered by narrow AI and machine learning. These systems analyze your typing habits and suggest words or phrases to speed up communication. By learning from your writing style and frequently used words, predictive text becomes more accurate and helpful over time. This technology saves users time and reduces typing errors. Finance industry leverages narrow AI and machine learning for tasks like credit scoring, risk assessment, and algorithmic trading. By analyzing vast amounts of financial data, machine learning models can identify trends, detect fraud, and make investment recommendations. These applications help financial institutions make better decisions and manage risks more effectively. Healthcare, narrow AI and machine learning are used for diagnostics and patient care. Algorithms can analyze patient records, lab results, and medical images to assist doctors in making accurate diagnoses. Machine learning models can also predict disease outbreaks and recommend personalized treatment plans. These advancements are improving healthcare outcomes and making medical services more efficient. Supply chain management benefits greatly from narrow AI and machine learning. These technologies help companies forecast demand, optimize inventory, and streamline logistics. By analyzing data from various sources, machine learning models can predict delays, identify bottlenecks, and suggest improvements. This leads to more efficient operations and cost savings for businesses. Energy companies use narrow AI and machine learning to optimize power generation and distribution. By analyzing data from sensors and smart meters, these systems can predict energy demand, detect faults, and improve efficiency. Machine learning helps utilities reduce costs and minimize environmental impact by making smarter decisions about energy usage. In agriculture, narrow AI and machine learning are used to monitor crops, predict yields, and optimize resource use. Sensors collect data on soil conditions, weather, and plant health, which machine learning models analyze to guide farming decisions. This technology helps farmers increase productivity, reduce waste, and make agriculture more sustainable. Smart home devices such as thermostats and security cameras use narrow AI and machine learning to adapt to user preferences and enhance convenience. These systems learn from user behavior to automate tasks like adjusting temperature or detecting unusual activity. Machine learning makes smart homes more responsive and energy efficient. Industrial automation is another field where narrow AI and machine learning are making a difference. Robots and machines equipped with sensors and learning algorithms can perform repetitive tasks, monitor production lines, and detect defects. Machine learning enables these systems to adapt to changing conditions and improve manufacturing efficiency. Security systems powered by narrow AI and machine learning can analyze video feeds, detect suspicious activity, and alert authorities in real time. By learning from past incidents, these systems become better at identifying potential threats. Machine learning enhances the effectiveness of surveillance and helps keep people and property safe. Personal finance apps use narrow AI and machine learning to help users manage budgets, track spending, and save money. By analyzing transaction data, these apps can provide personalized advice and detect unusual activity. Machine learning makes financial management more accessible and effective for everyday users. Language translation tools such as Google Translate rely on narrow AI and machine learning to convert text and speech between languages. These systems learn from millions of examples to improve translation accuracy. Machine learning enables real-time translation, breaking down language barriers and connecting people around the world. Social media platforms use narrow AI and machine learning to analyze user posts, detect trends, and filter harmful content. By processing vast amounts of data, these systems can identify emerging topics, recommend content, and protect users from abuse. Machine learning helps social media companies create safer and more engaging online communities. Gaming and entertainment, narrow AI and machine learning are used to create smarter opponents, personalize experiences, and recommend content. Game developers use machine learning to design adaptive gameplay and realistic environments. Streaming services analyze viewing habits to suggest movies and shows. Machine learning makes entertainment more immersive and tailored to individual preferences. Education platforms use narrow AI and machine learning to personalize learning experiences, recommend resources, and assess student progress. By analyzing student data, these systems can identify strengths and weaknesses, adapting lessons to individual needs. Machine learning helps make education more effective and accessible for learners of all ages. Weather forecasting has been transformed by narrow AI and machine learning. By analyzing data from satellites, sensors, and historical records, machine learning models can predict weather patterns with greater accuracy. These forecasts help people plan their activities and prepare for extreme weather events. Machine learning is making weather prediction more reliable and timely. Retailers use narrow AI and machine learning to optimize pricing, manage inventory, and personalize shopping experiences. By analyzing customer data and market trends, these systems can recommend products, predict demand, and prevent stockouts. Machine learning helps retailers stay competitive and meet customer needs more effectively. Transportation companies use narrow AI and machine learning to optimize routes, predict delays, and manage fleets. By analyzing traffic data and delivery schedules, these systems can suggest the most efficient routes and reduce fuel consumption. Machine learning improves the reliability and cost-effectiveness of transportation and logistics operations. As narrow AI and machine learning become more widespread, ethical considerations are increasingly important. Issues like data privacy, algorithmic bias, and transparency must be addressed to ensure that AI systems are fair and trustworthy. Developers and organizations have a responsibility to use machine learning ethically and protect users' rights. Despite its many benefits, narrow AI and machine learning face several challenges. These include limited generalization, data quality issues, and the need for large amounts of labeled data. Additionally, narrow AI systems can struggle with tasks outside their specific domain. Overcoming these challenges requires ongoing research and innovation in machine learning techniques. Future of narrow AI looks promising, with machine learning driving continuous improvements in performance and capability. Advances in algorithms, data collection, and computing power will enable even more sophisticated applications. As narrow AI becomes more integrated into everyday life, it will continue to transform industries and enhance our experiences. Machine learning is truly at the core of narrow AI development. Its ability to learn from data, adapt to new situations, and improve over time makes it indispensable for building intelligent systems. Whether it's powering voice assistants, detecting fraud, or optimizing supply chains, machine learning is the driving force behind the rapid progress of narrow AI. Sum up, machine learning plays a vital role in the development of narrow AI. It enables systems to learn from data, specialize in specific tasks, and continuously improve. From healthcare to finance and from entertainment to transportation, narrow AI powered by machine learning is transforming the way we live and work. As technology advances, we can expect even more innovative applications in the future. As we look ahead, the partnership between machine learning and narrow AI will only grow stronger. Continued research and development will unlock new possibilities, making AI systems smarter, more adaptable, and more useful in our daily lives. By understanding the role of machine learning in narrow AI, we can better appreciate the technology shaping our future and prepare for the exciting changes to come.